We have a S-gauge automatic passing siding here in the camera. The direction of travel is away from the camera. This is sort of a specialized system set up for using two American Flyer switches, and we use a set of automotive relays and reed switches to activate the relays to automatically control two trains here. It consists of a slowdown block incoming and then two stop blocks to stop the trains. This is the main line out here coming into the passing siding. Where this arrow is, there's a gap in the track which defines the beginning of the slowdown block. We have rheostats, we can slow the trains down coming into this part of it. So we go through the incoming diverging switch, and this would be slowdown section we're looking at. Here's the reed switches in the track, and there's gaps here to define the stop block. There's actually two gaps in this branch over here, and there's a single gap in here as indicated by the tape. So that's where the engines will stop, and the stop block continues up through the switch. And here's another gap that defines the end of the stop block, and this is main line out here. Just overviewing the control unit, we can see there's two rheostats. This rheostat controls the voltage in the startup block, or the stop block, the start-stop block. This rheostat controls the voltage in the slowdown block. And here's our relays, which actually control these American Flyer switches. The reason we have these automotive relays in the system, and the wiring diagram for that was developed by Mark Anderman, that these American Flyer switches consume so much current that if you try to drive them directly with a reed switch, it just blows the reed switch out. And you might even use like a railroad concept switchmaster in other situations, but again, because of the high current, we think each one of these switches takes around 3 amps, so for a pair of them you're talking about 6 amps, which is a lot of current. So we use a relay. These automotive relays are rated for something like 30 amps a piece. So one relay sets them to curved and one relay sets them to straight.
The slowdown, the 1015U, now known as the 10153, a single isolating track, is just slightly behind where you can see in the camera. So as you see the trains enter the field of view of the camera, they're already in the slowdown section. The slowdown section is controlled by the rheostat and runs the trains in the yard at reduced speed, so that as they come into this system of switches, they're running at a reduced speed just to give them a more realistic appearance, and also help them go through the switches with less chance of derailing. You can see the train pulling out of the yard is on the rightmost track, which I refer to as track number 1, and this system sequences from the right to the left as we're viewing it now, track 1 being on the right and track 4 being on the extreme left. So as we're looking at it now, it'll sequence from the right over to the left. In other words, the train on track 2, which is the first track in from the right, will be the next train that departs the siding.
Taking a closer look at these relays that we use to control the flyer switches, here's a couple of them by themselves. This is actually an automotive relay with a rectifier glued on top of it and connected up so it can be used on with AC current, because the relay actually has to be driven by DC current. But if you put AC current into the input tabs here, this will rectify it so it'll be DC when it gets to the relay. And if you ask where I get these, oh, and there's one of the magnets like we showed you a minute ago on the drawbar of the steam locomotive. If you ask me where do I get these magnets and where do I get these relays, I get them from a gentleman named Mark Anderman on eBay currently. Going back to the reed switches, I've got a magnet on the end of this steel bar. If we can see the far switch, when I hold the magnet down next to the reed switch, that activates, the reed switch activates the automotive relay, which in turn throws a track switch. And although it's out of the camera, the rear switch is doing the same thing. These relays are actually throwing two switches. Now these two freight cars parked here have magnets on the bottom of them, so if I roll this car over the reed switch, that one will set it to curved. If I roll this other car over the reed switch, that'll set it back to straight. So this is how these are normally activated. You've got magnets on the bottom of either the cars or the locomotives to activate the relays, to activate the reed switches, which in turn activate the relays. This concept is basically based on large-scale LGB-sized trains. They've been doing this automatic passing siding stuff for years, and other similar automatic things. Everything is plug and play in G-scale. For S-gauge, you've got to do quite a bit of hacksawing and adapting. The first problem is the engines. What helps a lot for this system, you can use stock engines, but it's much easier if you use this one's got a S&S can motor in it. I'm stuck on the magnet here. This has if you look inside the cab, you can kind of see the S&S can motor. It's actually a half-speed can motor, which drops makes the train travel makes the engine travel about half as fast as a stock American Flyer engine. It makes it run a lot slower and smoother. That's the first major change we'd recommend making. And then the other change is these are S-Helper tender trucks. They have 8-wheel pickup. Your stock American Flyer tender is normally 4-wheel pickup, 2 on each side, so you have a lot more trouble with engine stalling. But those are the two major modifications. Change the tender trucks for 8-wheel pickup and put a can motor in with a half-speed reduction to make it run slower and smoother. In the case of these engines, if they've got a metal drawbar that runs between the engine and the tender, you can see the little round magnets stuck there. That's where we can mount the magnets on some of the steam engines to activate the reed switches. A couple more comments on the construction of this control unit. The control unit's actually built on a separate piece of wood and can be detached from the track unit. It's kind of a tangle of wires. It's the first one I've ever built for S-gauge to do this function. If you move this control unit back further away from the track, you could cover it up or have it in a completely different location. You wouldn't have this tangle of wires sitting out here. But for a portable unit to be used on displays like this one is, we were trying to make it as slender as possible just so it wouldn't take up space. In fact, you can see there's a second track in the rear there, so our unit can't be too wide. You can see what we've done. We slimmed the control unit down so the whole thing fits on the 8 inches width of the track unit. The other unit you see in the system here is the automatic block, which we covered in a previous video. These are both controlling 2 trains on each track. The block, which is the one covered in the previous video, does it by maintaining spacing between 2 trains on the same track. The passing siding, which we're talking about now, that operates 2 trains on the same track by parking one while the other one goes around. Then when the one on the main line comes into the passing siding, it stops that one and starts the other train up. As you look at our power packs, we're operating right now. We've got this is a DC power pack. We're running that on the outside loop. The inside loop is being controlled by this AC American Flyer transformer. You can operate these controls really on, you can use them with AC, DC, or DCC because they're basically on-off blocks. They'll stop current to the engine and stop the engine regardless if that engine's running on AC or running on DC or running on DCC. Looking at these rheostats again, if we go back to the automatic block, this one has a single rheostat. Here's the stop block. From here, there's a direction of travel again to the left. The stop block is from here back to here, and the slowdown block is from here going back to here. So trains travel to the left as you're looking at it. They come in under a mainline power here. They hit the slowdown block. They run at a reduced rate of speed up through the slowdown block until they come into the stop block and they stop. And then when the block turns to green to start them up, they start up again at a reduced voltage as controlled by that rheostat, travel under reduced voltage until they hit the main line and take off. This has a single rheostat to control both of these blocks. This is slightly more sophisticated. It has a separate rheostat for the startup block, the stop block, startup block, and it has another rheostat for the slowdown block. It just allows you to adjust those voltages independently. You can do it either way, but having two rheostats gives you a little better control.